This is an animation showing the titration of a weak acid and a strong base. If you want to pause the video, I'm going to actually scroll down here so you can see it better, and you can read over this. However, what it says is that it's an animation on the molecular view of this weak acid, HA, reacting with a strong base, NaOH, but Na is not shown here because this is the net ionic equation, forming your conjugate base of A -1, and of course that water that's being formed. Because remember, even though it is a weak acid, acid plus base gives you salt and water, right? It's a neutralization reaction. So we're going to show you the different spots in our titration curve. So we're going to show the starting of the titration. We're going to show you that buffer region and what the particles are going to look like. We're going to show you the stoichiometric point. That is the equivalence point, and of course when we have excess NaOH. Okay, so I don't really want you even reading down here yet until we get to that point. So what is being shown in our solution? Well, the H2O that we're using to dissolve the HA is not shown in solution because that's not really part of the reaction. So right now all we have is the weak acid running around in solution because it's going to stay together as a molecule. That's why it is weak. All right, so what are we going to do? We're going to we're going to show you this buffer region, and we're going to add some NaOH. NaOH comes in, breaks apart, but did you notice that that OH reacted with the HA, making the reaction go to the right? So it says NaOH dissociates into your two ions. The hydroxide is going to react with that HA, producing that water. And again, we're not really interested in that water, right? First of all, it's a liquid and it's not part of that Ka expression. So now we're going to add more NaOH to make that buffer. So right now we really don't have a buffer yet, but what we're doing is making that buffer. We're resisting that pH change, okay? So we still have lots of HA. As we add that NaOH, it's going to break apart, and that OH is going to react with the HA, pushing it. Now notice we have less HA molecules, so let's add a little bit more. So now at this point, we are halfway. We are at that buffer region, okay? So it says here on the bottom, I don't know why they list the stoichiometric point first, but I'm going to read that second statement. At the half neutralization point, the major species are HA, I see them in solution, and A minus. At the end of the, okay, hold on. Yep, that's all I'm going to read there. So we still have some HA and we still have A minus, okay? This is our halfway neutralization point. This is our buffer region, okay? So let's continue on to the next part. Aha, now all of the HA molecules have been reacted. Now, whatever we started with, now they're all gone. Why? Because they all reacted with that OH minus from that base. This is what we call the stoichiometric point, or I like to call it the equivalence point. We want to remember that it is very important to understand that because it's a weak acid, this equivalence point is not 7. Why is it not 7? Well, again, think about what we have in our pot, right? We have A minus. Now we have H2O, right? Because we're kind of pushing the reaction the other way. And it's going to equal that HA and OH minus, okay? So in this point, we have our strong base equaling our conjugate base, right? And we've kind of eliminated that HA and those water, okay? So let's read this now on the bottom. Note that until we reach the stoichiometric point, OH is in deficiency and completely consumed. So again, at the stoichiometric point, the species is A minus is that conjugate base, right? Because A minus is a base, the pH is going to be greater than 7. So that's why our stoichiometric point is not 7, because it's not strong. It is now going to be greater than 7 because it is at the, that conjugate base is really prominent. Let's continue on, and we're going to add some more NaOH. Once we are past that stoichiometric point or that equivalence point, the pH then is determined by those additional OH minuses. So now we have more OH minuses that are going to say, oh yeah, our pH now is going to be that excess NaOH value. Okay, so hopefully you drew the titration curve and those particle representations.